Hello. We're going to be taking a look at the 2.3 lesson today, which is called Same Position. So our warm-up here has a little video. It says please, it doesn't say please, it says press play to watch the animation. Write a story about what you see. So we can watch the video. We see this overview of some cars. We notice that it takes 6 seconds for the yellow car, this taxi, to be caught up with that blue car. Beautiful. So just take a second now, write a story about what you see, anything that you notice. And when you're all set, let's do some exploring and push ahead to slide 2. Slide 2 says the car and the taxi are moving at constant speeds. So if a speed is constant, it means it's staying at that speed. It's constant, right? The car position is 14t plus 18, and the taxi's position is 17t. At what time t will the car and the taxi be in the same position? And maybe you remember it from the movie that we saw in the previous slide. But what we can also do is take these expressions, 14t plus 8, and set it equal to 17t. Because we want to figure out when these two expressions will be the same. So how would we go about solving this? We know that we have our yellow car here at 0 meters, and oh, I wrote it wrong. It's 18, not 8. There we go. So the first thing that we can do is we can subtract 14t on both sides. 14t minus 14t cancel out to 0. So we're just left with 18 equals 17t minus 14t is 3t. And then we are gonna, since this is multiplying by 3, we're gonna divide both sides by 3 to get t equals 18 divided by 3 is 6. And we notice that if you hit try, we see that at 6 seconds, the blue and the yellow car are lined up completely. I'm going to clear my screen. When you are all set, push ahead to slide 3. This says that the truck and the car are moving at constant speed. So now we're looking at that truck all the way in the left lane and the car in the middle lane. Enter different times and press try it. So let's try 2. So how long will it take for the truck to get up to the car? Let's try 12. Because there's the yellow car at 6. The truck is not getting anywhere near it. It's still so far away. So what do we know about when the truck and the car will be in the same position? Let's try 20. Right, we can try these bigger numbers, and it just doesn't look like it's ever going to happen. These two expressions, 14t and 14t plus 18, can never actually equal each other, because they both have that same rate of 14t, but we notice that our blue car is plus 18 ahead of the truck. So the truck is not going faster, so it's never going to actually be able to catch up to the car. And this is going to happen with some equations. So let's take a look at what that can look like when we're dealing with equations. Slide 4. This is what the work can look like that we did. So we did 14t equals 14t plus 18. When we subtract 14t on both sides, 14t minus 14t cancels to 0. So we have 0 equals 0 plus 18. But of course, we know that 0 does not equal 18. This is a false statement. So When we get a false statement like this, it means that there are no solutions, or there are no values of t that will make both equations true. So this is what can happen sometimes with some equations. If we get this false statement, then that means that these two equations have no solution. There's not an answer that can satisfy the equation. Let's look at slide 5. This equation represents when these vehicles will be in the same position. So we have 18t minus 4, and then we have 12t plus 20. How often will they be in the same position? What do we think? Let's try our seconds. So let's see what happens if we set these equal to each other. 18t minus 4 equals 12t plus 20. So if we set them equal to each other, we can subtract 12t on both sides. 18t minus 12t is 6t minus 4. 12t's cancel, and that's just equal to 20. And then since this is a minus 4, we can do our opposite operation and add 4 to both sides. And we get 6t equals 24. And then finally, since this is 6 times t, we can divide both sides by 6 to get t alone, which is going to equal 4. So let's look after 4 seconds. Boom, they're at the exact same position. Wow, that car is moving fast. Good. This is a repeated challenge, so these are many challenges. You can continue to try and work through them. So here's another one. 15t plus 11 equals 15t. So when we subtract 15t on both sides, cancels, and we just get 11 equals 0, which of course is false, which means it will never happen. They're moving at the same rate. It'll never catch up to the yellow car. So do as many of these repeated challenges as you would like. There's a couple more, so you can keep getting that practice of solving the equation and see, do we get a solution or is it no solution? Beautiful. Okay. Let's take a look at slide 6 when you're ready. It says compare and contrast. Here are Jazz's and Nicole's strategies for solving a challenge from the previous screen. Is each strategy correct? So let's take a look. 12t equals 20t. They subtracted 12t on both sides. That looks good to me. And then we got 12t minus 12t is 0 equals 20t minus 12t is 8t. Then they divided both sides by 8. 0 divided by 8 is 0. And the 8's cancel, so we're just left with t. So this means at time 0, they are in the same position. So that one looks good to me. And then for Nicole, 12t, they divided both sides by t, which is not how we want to go about this type of problem. 12 is not equal to 20, so this would be does not equal each other. If I was solving this problem, I would want to subtract 12t on both sides. I wouldn't want to divide out that t. But yes, this is never meet. Okay. On slide 7, we have once, always, and never. And we want to sort these different equations. So let's look at the first one, which was t equals t plus 2. So if we were to solve this, I could subtract t on both sides. T minus t is 0 equals 2, which is false. So this one is going to be never. Beautiful. 2t equals 8t. We could subtract 2t on both sides. 2t minus 2t is 0. 8t minus 2t is 6t. And then we could divide both sides by 6. And we would get 0 equals t, which would just mean at times 0 second, it is meeting once at 0. So this is going to be once. Beautiful. This next one is t plus 1 equals t plus 1. This is going to be infinitely many solutions, or always, because it's the exact same on the left side and the right side. So this is always. That means the cars are just staying next to each other the whole entire time. 8 times t plus 1 equals 8t minus 8. So when we distribute this 8 first, we get 8t plus 8 equals 8t minus 8. If we subtract 8t from both sides to get our t's together, notice these will both cancel out on both sides, and then we're left with 8 equals negative 8, which is not true. So this is going to be another never. Those cars are never going to meet. 12 minus t equals t minus 12. Okay, let's add 12 to both sides. 12 plus 12 is 24. Minus t equals t. And then I'll add t to both sides to get 24 equals 2t. Divide by 2. 24 divided by 2 is 12. So this is going to be another one for the meeting once. And then finally we have 2t plus 6 equals 2 times t plus 3. When we distribute this 2, we end up getting 2t, 2, and then plus 2 times 3 is 6. So on both sides we have 2t plus 6 equals 2t plus 6. So this is an example of always, since those equations or those expressions are the same on the left and on the right. Beautiful. Make sure they're snapped in and sorted. You should be able to move them as a whole group. And once you're all set, you can push ahead to slide 8. Daryl and Jasmine solved t plus 1 equals t plus 1 and got 0 equals 0. Daryl says they'll never be in the same position. Jasmine says they'll always be in the same position. So when the variables cancel here, because what they did was just subtracted t on both sides, and then those variables canceled out, and they were just left with 1 equals 1. Now this is a true statement. So when this happens, this means it is infinitely many solutions, so they'll always be in the same position. So this would be Jasmine. And what this means is we can put any value of t in and the equation will be true. If t is 3, 3 plus 1 equals 3 plus 1. If t is 10, 10 plus 1 equals 10 plus 1. We will always get a true solution. So on the next slide, for slide 9, here's some more exploring, get some more practice in. It says the truck and the car are moving at constant speeds. Write an expression in terms of t for the position of a taxi that makes both statements true. The taxi and the truck will never be in the same position, and the taxi and the car will be in the same position when t is 8. So the taxi, so if we make the taxi and the car the same rate of 12t, then they start in the same position. So we'll want to add an amount. So 12t plus what would get us Let's see, when t equals 8 for, oh, we're about to run out of time. Hold on, check part 2 for the rest of this. Part 2.